Rawr. Okay. So what would this mean? So whatever function I give you, wouldn't that be the output for something, right? F of x is the y, it's the output, correct? So what does it say to cut in thirds, the output? You with me? If it was inside instead, what am I cutting in thirds? The input. Yeah, so that would be very different. Yeah. What do you mean? Oh, okay. Let's do a specific example. F of x is square root of x. Right? And we should all be able to graph the base graph square root of x. So it'd be 0, 0, 1, 1, 4, 2. So if I want to graph, let's see, do I have 3 colors? I think I do. Do I have 3 colors that would work? That would be neat. Oh well. Oh, there. If I want to do g of x equals 1/3 square root of x, what would that tell me to do to the graph?
Is it the vertical? No.
So here's square root of x. Don't even think about what it's called. Isn't that the outputs of the original function, right?
So
And what do I want to do with every one of those outputs? I want to divide by 3. So this used to go to 1. So now it goes to 1/3. This used to go to 2, now it goes to 2/3.
So that would be a horizontal stretch, correct?
That would be a vertical compression. I don't give a shit about the names.
Okay.
The names don't matter worth shit. But if it's only outside, what's the outside? Isn't it up and down? Outside's up and down, right?
Uh-huh.
Didn't I just smush it down? Okay. So Jeff, what if I had h of x equals square root of 1/3 x? So when it's inside, is that up or down or left and right?
It's gonna flatten it toward the y-axis.
No.
No?
What's the very first thing that happens when I put a number inside? Like if I put 9 in, what's the very first thing that's going to happen?
It's gonna become a 3.
It's going to get cut in thirds, correct? You guys with me?
Yeah.
So don't my inputs have to be 3 times bigger than they used to be in order to get the same output? What do I have to put in here to get a 3 out?
A 9.
A 9. Is everybody with me? If you put a 9 into the square root, you get a 3 out. The inside has to be 9 for me to get a 3 out, correct? What do I have to put in now to get a 3 out? 27.
Oh.
So, help me out, guys. Remind me, which way would this go? Which way would this go? Which way
To
would this
the
go?
right.
Right. Good. Why? Because when it's inside, it does the opposite of what it looks like. Why does it do that weird shit? Because it's taking 1 away, so I got to come in with 1 more than I used to have, right? It's like the guy at the door that steals $1 from you. Strangely polite mugger. Just need $1. Thank you. Leaves all the rest of your money. You guys kind of with me? So I need $1 more with me to make sure I make up for that lost $1. So this is the mugger that takes 1/3 of my money. So don't have to come with 3 times as much money as I need if I'm going to always get 1/3 taken away. I need you to understand. So doesn't this look like, that's a minus. Why doesn't it go back 1? Because I have to make all my inputs bigger. This is a 1/3. Why won't it smush it this way? Because I got to be 3 times as big of an input. So I used to put a 1 in to get a 1 out. Can anybody tell me what do I put in here to get a 1 out? 3. 1/3 of 3 is 1, square root of 1 is 1. Is everybody with me? Isn't that 3 times as big as it used to have to be? So this would make it stretch this way. So now 3 would give me a 1. 0 still gives me a 0. 3 would give me a 1. 4 used to go to 2, now 12 would go to 2. Holy shit, so this is going to be like that. So that would be stretching it this way, okay? So when it's inside, left and right. And it's the opposite of what it looks like. When it's outside, up and down. And it does what it looks like, right? Yes?
I had another question.
Wait, real quick. On this one, any leftover questions? And again, this is what we call a compression or a stretch, and I don't care about the names. I just care that you do them, right? Stretch, compression, whatever. It doesn't matter. Yeah.
When it asks if like in an equation if it's even or odd, do you just look at power if it's even or odd? Or
What was the test for even or odd? So if I'm given a function, how do I test it to see if it's even or odd? Plug in a negative x. If the answer I get is exactly the same as what it was at first, that's even. If the answer I get is exactly the negative of what I had at first, that's odd. And we talked about why that is. It's because this is even, it's got an even power. So sure enough, when I plug in a negative, I get the exact same output as I did before. This, whatever output I got before, I'm not going to get the negative of it, right?
what would be like neither? Would it be,
This is neither.
oh,
Yeah, so if I put a negative x in, what does the square do to the negative? What's the square do to the negative? Kills it. What's the fifth power do to a negative? Still there. Is this the exact same? Is this the exact negative? No. So that's neither. That doesn't have either symmetry. Yeah. If you graph it, it's not going to have a mirror image around the y-axis or around the origin, which is the weirder one. Okay, maybe. Yes.
So how did you find that, like, that line real quick?
The blue one?
Yeah.
So, I used to put 1 in to get 1 out. Now I have to put 3 times as big, because the first thing I do to an input is cut it in thirds. So now I have to put a 3 to get a 1 out. I used to put a 4 in to get a 2. Now I'm going to have to put 12 in to get 2. What do you get when you put a 12 in here? What do you get? 1/3 of 12 is 4, square root of 4 is 2. Now all my inputs have to be 3 bigger than they used to be to get the same output. That's why when it's inside, it does the opposite, because whatever's happening to this poor little dude, I have to overcome. You cut him in thirds, he better come in 3 times as big as he used to be, right? If it's outside, it's just whatever it used to be, cut in thirds. So it just does exactly what it looks like. It's kind of nice. Outside, up and down, inside, left and right. Okay. Very quickly, one quick example I want to do, because it's kind of nifty. So what would this do? Have the base function.
Go by a factor of 2.
Yeah, so now I double all my outputs, correct? So this would double, the 0 is still 0, the 1 is now 2, and the 2 is now, you could do it, Jeff, the 1 is now 2, and the 2 is now 4, oh, there it is. 2 is now 4. So everybody agree that that stretched it up? Now, what would this do?
That's gonna compress it.
Well, all of my inputs can now be 1/4 as big as before. Do you see that? I need you to see it, because the first thing I do is quadruple it, right? So to get a 2, what did I have to put in into the base function? I had to put 4 in, correct? Now I just have to put a 1 in to get a 2 out. So that would take this point and move it back to here. Do you see how these are the same? Why are these the same? This is a stretching up, and this is a smooshing it back. If I stretch it up or if I smoosh it back, it's the same stupid picture. Why? What is the square root of 4?
2.
Frickin' 2, yeah. So that's an example of, if it's inside, it's either a compression this way or a stretch this way, because inside's left and right. If it's outside, it's either smushing it or picking it up this way, because outside's up and down. This is a beautiful expression of it. You can simplify this and make it outside, but it's the same stupid picture. Okay, enough of that. So that's just one piece of the transformation stuff, right? It's when there's multiples, there's coefficients. Let me catch up real quick to who has not gotten their quiz back. You took it? Oh, there you go. Corrections, of course. Oh, so I'll go back here.
The only thing I always draft is
Corrections, of course. Is that everybody? All right. Let me see. Oh, here. All right. So, anybody else need a copy of the practice test? Do I need a copy? There it is. Everybody good on that? Practice test, okay. So I have the answer key, I'll give it to you later. So just to remind you guys, today is review day. We've been through one of these already. Right, when is the test? Monday, yes, I like it. So ask away. If you have any questions, it can come from the practice test, the quizzes, the homework.
Just a general question.
Sure.
I'm kind of confused how to complete the square when the b value is an odd number.
Oh.
Then you get a you can get a
No,
decimal.
you never get a decimal, you get a fraction.
Yeah.
So here's the beautiful thing about, I'm almost certain none of you guys would use that adjective, but completing the square is just so brute force. So for example, let's say I have this here. And I have to put this into vertex form where I can see the vertex. You with me? What would you do first to accomplish that?
Divide 9 by 2.
No, I would
Take
not.
out the 3.
Oh,
Take out the 3. And of course, move the 2 over. Got it. Now, what do you do?
Now you divide the 3 by 2.
Good, and you
And
get 3
square it.
halves, and you leave that poor little dude like 3 halves, and then you
Square it.
square it. And you get, and you leave that poor dude as 9/4, right? Don't make decimals, that just makes everything look worse. As much as you might dislike fractions, they actually make things look cleaner. So what do I do with this thing?
Multiply it by 3.
I'm always curious, I'll tell you what to do with that. No. Do what now, sorry? Yeah, I'm gonna add it right here, right? I'm gonna add, so this is all side work.
Yeah.
What did I actually just add?
27 over 12,
Nope,
or minus.
it's only a 3, it's not a 3 over 3. So what did I actually just add?
Oh, 27 over 4,
27 fourths, so what do I better do at the same time?
minus that.
Minus 27 over 4. Now, it's a fraction, correct? That's not a lot of work yet. The most work you're gonna have when the middle term is not even, because that's the one time you're gonna get a fraction for the middle, right? The most work you're gonna have is what we're gonna have to do right now.
Minus 1 minute.
Don't I have to get these together? Right? And this should not be a problem, right? How do you get those together? Yeah, you're gonna multiply this by, so you get negative 8 minus 27 is? Negative 8 minus 27?
19.
Negative 35, they're both negative, so you can't forgive debt, unfortunately. Right? I'm losing them both, yeah? And what's inside here? You wanna factor that? I don't want to either, but I don't need to. What goes on the inside? 3 over 2, yeah. That's the nice thing about completing the square. The worst part about that was getting an LCD for that part right there.
Yeah, because 1.3 over 2 is 1.5, 1.5 is 5 over 3.
I have no idea what the hell you just said. Do it again.
3 over 2 is 1.5.
I don't want that. Don't do that. I don't care. Okay.
Wait, so why did you multiply by 4 again?
Where? Oh, to get these together, right? To put these
Oh,
together.
okay,
Yeah. Because if I don't put those together, I can't tell what my vertex really is.
Okay.
The 3 over 2, is that, yeah.
So again, this tells you what you have to add in order for this to factor like this. So you never have to do this factor work. You already know what the answer's gonna be. That's kind of a nice built-in thing with completing the square, you guys are all with me. Again, I think our brains see this and go, man, that's hard. I mean, look at that. Is that pretty? No, but the hardest thing about this was right there. That cannot be hard, just getting LCD. Don't let that be difficult. What's the vertex of this?
A minus 3 over 2, comma, minus 35 over 4.
Yeah, cool.
Okay.
That's a good example of a parabola I would not make you graph by hand. I'm not gonna make you try to find that point. You guys understand? Okay. I am gonna make you graph a parabola by hand. It's just not gonna have quite that gross of a vertex. Something a little easier to graph by hand. Are you guys with me? Will this open up or down?
Down. Right?
Up.
Up.
Oh, I did see.
It's positive, so it's gonna open up.
Oh.
You guys all right?
Oh, that's an equal, I thought it was a minus.
Nope.
Okay.
Yes.
It's a,
Did you 3 on the practice test?
Yeah. Let me see. Oh, well, there you go. This is exactly like what we're just doing. Oh, let me get rid of some of this stuff here. I'm not sure how many 8-foot-tall teachers there are. So this guy might be. Weehaw. Okay, so you would do the exact same thing, but why is the problem I gave you there nicer than that one? Yeah, even when you take a 3 out, isn't it still gonna be a -6? It's even, so when you cut it in half, you don't get a fraction. You guys see what I'm saying? Yeah, so you do the exact same thing we just did, get the vertex for it. What's the y-intercept? 0.2, yeah. You guys semi with me? Yes.
Standard form is just the way solid force that?
Yeah, I call it standard form. I think the book calls it something else, but or you can call it vertex form. So it's this form here where I can just read off the vertex just by looking at it. Sort of like slope intercept form means I can read off the slope and the y-intercept. So maybe a better name would be vertex form. Yeah. Okay, if you tried out the practice test, let me know which ones gave you the most trouble. Yeah.
Could you do number 8 in the practice test?
Hey. Yeah. All right. Oh my God. Come back. All right. From the very first sentence, what can you immediately write in Mathish from that English?
Speak friendly bitter.
The sum of the base and the height. So, which things do you not know in this problem? Holy shit. So what do you want to call the base? No way. What do you want to call the height? Holy shit. Okay. So can you guys are all with me so far? You identify the parts of the problem you don't know and you give them variable names. By giving them variable names, I'm able to do stuff to them. If I knew the numbers, I could do stuff to the numbers, but I don't know the numbers, so I give them names and I do stuff to the names. First sentence, what math equation does it become?
B plus H equals 46.
B plus H equals 46. The sum of B and H is 46. So that's one thing I know. This is what they tell me. What do they ask me for?
The maximum area.
Maximum area. So they ask me for the area. What's the formula for the area?
That's B times H over 2.
Yeah, it's half base times height. You guys know that, correct? So again, if I have a parallelogram or something, base, height, the area is base times height, and a triangle is going to be half of that. That's where that formula comes from. That's all it is. So, how many variables are in this? There's like 3 really, if I count the area. This is too many. Don't I know this? This is true, correct?
B plus H.
Can I solve this for one of the letters? Pick a letter. What do you want to solve for?
B.
B. So how do I solve for B?
So
No,
B-
definitely not. I'm not trying to find the intercept. I'm trying to solve that equation for B. I want to know what the base is. So how do I solve that for B?
I'm factoring 46.
Say again?
You start by finding numbers that would multiply 46.
Oh, no, there's way too many words happening. How do I solve this for, how do I get B by itself? Minus H, okay. Right? So do I know what the base is now? Yes. In terms of algebra, I do. It is 46 minus H. Anywhere I see B, I can replace it with 46 minus H. And why does this make sense? If the sum of the base and the height is 46, what's the base if the height is 20? If the
46 minus 20?
26, right? So that's 46 minus the height is what's left over for the base. Does that make sense? If the base was 10, what would the height be? 36. 46 minus 10, right? Okay. Can I rewrite the area formula now? What can I replace in the area formula? What do we know? We know what B is. What's B? Alright. And then what can you do with this? Distribute it. So let's see if we can do this. I can do a half and then times H. Is that cool? So half of 46 is
23.
23 and then times H. Half of H is half of H times H is half of H squared. Is that parabolic? Which way is it opening? Is that an equation of a parabola if I graphed it? You don't have to graph it, I'm just saying. Which way would it open?
That one.
Does it have a max or a min? Maximum. And look at what the question is asking me. Question is asking me to find the maximum area, correct? So where's the maximum gonna occur on this downward parabola?
At the vertex.
At the vertex. Do we have a shortcut to find the vertex? Yes, we do. Now you gotta be really careful because I've written this out of order, correct? So the vertex formula, the shortcut is negative b over 2a, right? That'll get you the input, so in this case it's h. What is b?
Half.
23.
Oh.
Right? It's a x squared plus bx, correct? This is just out of order. Doesn't change what b is. So b is 23. What's a?
Half.
Negative a half. The beautiful thing is the negatives cancel, the 2's cancel, so I get the height is 23. What's the question asked for?
Maximum area.
Maximum area. This is where the maximum area happens. How do I get the maximum area? Plug it into the area formula, right? You guys with me? Don't have an area formula right there? So if I know h, I can plug it in and figure out what the area
You
is.
know that A was 1/2.
What's a, b, and c? What's that relate to? What's the form that a, b, and c come from? ax, ax squared plus bx plus c, correct? So a is the coefficient of the squared term. Ax squared plus bx plus c. What's the coefficient of the squared term in the area formula right there? What's the coefficient of the squared term in the area formula?
Oh, minus 1.
What's the squared term?
H. H squared is.
1/2 h squared, right? So what's the coefficient of the squared term? Negative a half. That's a. What's the coefficient of the h term, the single letter? 23. That's b, right? All this is if I, guys,
Oh, since it's negative 1/2 flipped.
I could write this like negative 1/2 h squared plus 23h. Yes?
Yeah.
So a is not the first number I see. That wouldn't make any sense. A is the coefficient of the squared term. It's gotta be. Just because they turn it out. So what's the slope in this equation? Is it 6? Is the slope 6? Yeah, why is the slope negative 4? It's in front of the x. Yeah. So just because they turn it doesn't suddenly make it completely change what it is. Right? Okay. So when I say negative b over 2a, it's just like quadratic formula. It's exactly the same a, b, and c, but I don't give a shit about c, which is nice. A, b, and c always come from the same place. A is the coefficient of the squared term, b is the coefficient of the non-squared term, and c is the constant, which is beautiful for c. C constant, kick ass. You guys have fun with me? So just because they put it out of order doesn't suddenly change everything, right? Okay. Yes?
You do, man.
Okay, sure, yeah. Did you have a question on the last one?
Yeah, so to find the maximum area, you would just plug that back in?
Yeah, now we know height, and I can just plug it back in here.
Okay,
Or
yeah,
you could figure out the base, right? If I know the height is 23, what's the base?
40. It's also 23.
23. And then could I just get the area by doing 1/2 times 23 times 23? If you do it either way, it's the same answer.
okay.
So I have an area formula right here, all I have to know is h, and I'll get the answer. Or, I have an area formula right here. I have to know base and height. I know height, I can figure out base, and I can throw stuff in there. Either one. They're both area formulas, so they both are gonna give me the same thing. Say again, sorry? Love you guys so much. So, if you, depending on which way you wanna do it, so if you wanna do it, like I just said, The base would be 46 minus 23. The height's 23. The base would be 46 minus 23. And then the area is 1/2 the base times the height. Throw that in the old calculator, right? You'll get exactly the same answer if you just plug a 23 in here for h, because that's what h is, right? Either way you do it, you'll get the same answer.
So does an isosceles triangle have maximum area?
Say again?
Does an isosceles triangle have maximum area?
Can you make an isosceles triangle as big as Earth? Yes. So in order to have a maximum, there's got to be restrictions. What's the restriction here? What's the restriction in this problem? Is it allowed to be as big as it wants to be? No, what's the restriction? The base and the height have to add the 46. That is why there's a triangle with a maximum area under those restrictions.
Right.
If I didn't restrict it at all, I can make the triangle as big as I freaking want to, and the area could be infinite. I make a triangle that surrounds our entire multiverse, right?
Well, what I'm saying is like, okay, you could have one leg that's like 40 centimeters and one that's 6 centimeters, and it still add up to 46.
Sure.
And it'd be like a super skinny scaling triangle.
Sure, totally.
But if you got an isosceles triangle, then you got legs of equal length. My question is that give you maximum area for all the possible triangles that could be created out of that length?
All right, that's a whole other level of a question.
Okay.
We're not going to do that right now. But I like it. It's kind of like related to if you have a rectangle, how do you have it make the largest area? Make it a square. We talked about that before. We did an example like that.
Makes sense.
There was the problem number, so I have a question about number 1, but there was also this one. What they got in front of the book, and those were finding the max or the min, if I remember correctly. Okay. So I have a question about number 1. What's evil about this problem related to the first question I asked? Bless you. The part B is beautiful. Why is part B so nice the way I've given you the problem?
Because you gave us all the zero.
I gave you factored form, so you can just tell me the zero is easy, right? And then the y-intercept, you have to plug a 0 in, but you'll get 0 anyway. Why is the first question harder? Because it's
Well,
factored.
you just have to multiply it out, and then you add the x, and that way, then you can determine if it's Egyptian or a problem.
Yeah,
Sure, yeah. So you definitely don't have to multiply anything out. But if you did multiply it out, can you guys see what the largest power would be on the x?
Third,
No.
right?
No. Oh, I'm sorry. Oh, you're getting, oh, okay. That's your flashing me a gang sign. Yes, it would be a 4th power. So how do I know that?
I'm counting the
If you multiply this out, what would the highest power of x be from this? 2.
Oh.
That gives you 1 more. It's 3 so far. 1 more, that's 4. I do not have to multiply it out. I can just think ahead. If I did multiply this out, this gives me 1x, that's another x, and that gives me 2. That's x to the 4th. Plus other shit. Do not multiply that out. That's crazy. There's no need to do that, right? So what would the end behavior be for this?
smiley face.
Up and up.
Up and up. Intercepts, easy. What are the x-intercepts? 0, 0.
0, 0,
2, 0.
0,
Negative 3, 0. And didn't I already write the y-intercept? If I make x 0, what do I get? I don't care what these are, that's 0, so I get 0, right? So that is also the y-intercept. 0, 0 is the one that's both. It's on both axes, so it's both an x-intercept and it's a y-intercept. Okay. Why can't I have more than one y-intercept in this problem? Because if I had more than one y-intercept, what test would it not pass?
Horizontal or parallel.
So it wouldn't even be a function then, right? So if you know it's a function, you're only gonna have one y-intercept, because otherwise it would not be a function if it came back, hit the y-axis again. You with me? Okay. It's very good so far. So if I don't give it to you factored, the first question's easier. If I do give it to you factored, the second question's easier, right? Okay. What the hell do I mean by behavior? Do you have to take a math psychology class or sociology? Math, sociology. What does behavior mean? There's two options of what it could do. Turn it through, or bounce, whatever the hell you want to call it, right? What determines which of those things it does?
Whether the exponent is odd or even.
Yeah, what's the only factor in that original function that has a even power?
0, 0.
In the original problem, what's the only factor that has an even power?
X plus 3.
Yeah, all right, x plus 3 is being raised to a second power, yes? That's the even powers. And which 0 came from that piece?
Minus 3.
Negative 3 came from that piece, right? So this guy has a even power, so it's got what we call even multiplicity, which means the root that came from it is going to do what a parabola does.
Bounce.
Yes. So negative 3, 0. You could say bounce. Man, I can't write the thing. Bounce or turn. What's it going to do at the other two?
Through.
Going to go through, because they have odd multiplicities. It's going to do what a line or a cubic does. It would go through. It wouldn't turn. That's really it. That's all there is to that idea, right? If a piece is squared or to a fourth power, to some even power, it's going to turn at that number. If something else is to an odd power, it's going to go through that. That's a good thing to know when I'm graphing, so I know if it's going to turn or if it's going to go through and then turn later. And then on the actual test, I'll give you a little more help on part D. I'll say find 2 more points, right? So if I plot what we know so far, we don't know much. What can I plot right now that we know? 0, 0.
2, 0.
2, 0.
Minus 3, 0.
Minus 3, 0. Yeah, that's all we know. Can you guys see good inputs to figure out to help you graph this?
Well, we already know that it's going to be
Negative
up and
2.
up.
Yeah, we know it's going to start up here, right? And then what's it going to do at negative 3, 0?
It's
It's
gonna
gonna
Good.
dip.
Going to turn, right? So it's going to turn at negative 3. So I want to know how high it gets right here. So what would I want to put in?
Negative 2.
Negative 2. I want to know how high it is at that point. So basically, a lot of the points you want to plug in are between intercepts. So you know what the shit's going on in between those intercepts, right? So if I plug a negative 2 in, I'm going to get negative 2 times negative 4 times 1 squared. You guys see how I just plug a negative 2 in? Bam, bam, bam. And what do you get when you multiply that out? 8, which is good. I knew it was going to be up here, because it starts up, it turns, it better be up here. What's a good point over here, of course?
1.
1. So if I plug a 1 in, I get 1 times negative 1 times 4 squared, which is?
Negative 4? Oh, squared. 16?
Negative 16, right?
Oh. Yeah.
Okay. So, what's the one axis I haven't given a scale to yet?
The y-axis.
Yeah, now I can. What have I done now that I know how to make this y-axis scale? Because don't I know a few more outputs?
Yeah.
So what kind of scale do you think I should use for the y-axis, considering where I have to get to?
Maybe 4s?
By 4 sounds good, right? Which is really cool, because 8, 16, go. So if I go by 4s, 4, 8, 12, 16, negative 4, negative 8, negative 12, negative 16, So 1, -16, and -2, 8. So what gets me started now that I have all these anchor points? What gets me started? What was the end behavior? Where does it start?
It's a smiling face.
It starts up here, right? So I'm going to start up here, exactly the same way it tells me. What am I going to do here?
Down and bounce.
I'm going to turn, and you can see, because that makes sense, because now I got to go through this thing. And then the other 2 intercepts I'm going to go through, so that matches through. Did I get the right end behavior?
Yeah,
Yes.
It's doing exactly what it's supposed to. I love it, right? How would you check this?
a shortcut?
It's no shortcut. How would you check this? Put it into your graphic calculator, yeah.
Oh,
Do not, you all know this. If you put in your graphing calculator and it's different, and I mean like really different, and you don't see where you made a mistake in the work, you could put a little note saying, it doesn't look like this in my graphing calculator. You're gonna get a lot more points if your graph is wrong and your work is wrong. I want your work to be shown on the graph. Does that make, that's part of what I'm testing you on is, can you take the work you've done and translate it visually? So if you made a mistake in the work, I want that to show up in the graph, and you're not going to lose any points in your graph. You're going to lose points on the work alone. Does that make sense?
okay.
If your work is wrong and your graph is perfect, you're losing points on both. Does that make sense? Students sometimes are confused, and I'm like, I'm not grading your calculator. I'm grading you, right? So it's a good way to check, and if you can't see what you did wrong, don't change anything. Don't make it match the picture on the calculator. Okay. So I could give it to you already factored. I could give it to you and you have to factor it as the first step. But again, whichever way, one of these 2 things is going to be easier. So.
Read number 7.
Yeah, let's see. Yeah. What 2 things do I need for the equation of a line? I need 2 things.
Y, you need to put it into find the Y.
I need 2 things. What do I need? Slope? Y-intercept would be awesome, but do I always get the y-intercept? No. So in general, I need the slope and any point. Did they give me a point?
Yes.
Yes, sweet. So I finally have a point. Did they give me the slope?
Yeah.
Not directly. Did they give me a way to find the slope? Yeah. What do I know about my line? I know it goes through that point, great. What else do I know about
It's
my line?
perpendicular.
It's perpendicular to that one. So if I only knew that guy's, if I only knew this guy's something, I could figure out my something. I'm perpendicular to him, right? What is related then? The 2 what's? If I'm perpendicular to another line, what's related?
Would be the
Slope.
opposite.
So if I knew this guy's slope, I could figure out my slope. Yes?
Yeah.
How do you figure out this guy's slope?
Y, you find the Y.
Solve for what? Kick ass. You guys still with me? So again, when I say find the equation of the line that does stuff, you're going to take it and break it into 2 parts. I need to know the slope. Did they tell it to me or do I have to figure it out? And I need to know a point. Did they give it to me or do I have to figure that out, right? So you're breaking the problem down into parts. One part is get the slope. The other part is get a point. Yeah.
So we get the slope, then we make it the opposite slope,
Sure.
and then we plug in the point
Plug in the point where?
into X and Y
X and Y where?
to get the Y-intercept. First we Y out the,
I'm with you. So my point is this. So I got the point. Check. How do I get my slope? Well, how do I solve this guy for y?
So X to 0?
No. Again,
move the Y, move 3, or move 5 over.
I don't have a clue what x is. I just want to solve it for y. I'm not solving for the y-intercept.
You move 5 over to
Yep.
the other side.
Yep.
And then you divide both sides by 3.
So add 5, divide by 3. Yeah. Let's see. Here. What's this guy's slope then?
2/3.
Do I care about his ugly looking y-intercept?
No.
Don't give a shit. The only thing that line is there to do is to tell me my slope. Because I'm perpendicular to him, that's all I care about. His slope is 2/3.
So you just put
So what's my slope?
negative 3/2.
Yeah, so his slope is 2/3. My slope will be the negative reciprocal. It's the complete opposite. Now, just to show you, you could, right there, you could use this equation. What goes here?
So
Good. What goes here?
-1.
Good, because that's the x piece, and there would go -3. Are you guys with me? And then you could just solve for y. Or you could actually do this. Now, do I know b? No, but I do know slope, and I do know not 2 points. I do know 1 point. So when x is -1, y has to be -3, and then I can solve for b. It's a bit of a shortcut, so you don't have to use this whole equation here if you don't want to. You can actually just solve for b. I know the equation of a line is y equals mx plus b. If I know m, and I know a point, I can actually solve for b, because that would be the only letter left unknown. So let's see, I would think this kind of thing should be not too horrible by now. We've done this a lot.
I have a
We'll see.
question for,
Yes?
9A. Is it only one of the, for 9A?
Yep. 9A, yeah.
Yeah, so, like, one of the answers doesn't, I don't know if it fits, like.
No, one of the answers won't work, yeah, if I remember
Oh,
correctly.
okay,
Yeah.
'cause I was wondering, cause the square root is either plus or minus.
What do you mean? No, 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 no.
Do you have an extra one of those papers around?
Practice test?
Yeah.
Yes. Okay, so. How many things do I square to get 9?
3, 2.
How many things can I square to get 9? 2, right, what are they? 3 and -3, right? So when I square root, I must put a plus or minus, right? When I square root, I have to put a plus or minus. If I have a problem just sitting there staring me in the face, what's the answer to that? 2. So square root's not plus or minus. Definitely not. That is the positive root of 4. How do I know? Because there's a positive, right? So if I wanted the negative root of 4, that would be the negative root of 4. So this symbol is the positive root. Okay. Is that all right? So then coming back to this guy, what would the first thing that I have to do here be? What would that be?
Add x on
Add
both
it?
sides.
Yeah. And then since I got the radical by itself, what can I do?
Square both
Square
sides.
both sides.
Square both sides. And the next biggest mistake I see is people don't square this correctly. Right?
Right.
You just say it's like x squared plus 36, but of course you have to write it twice, FOIL it, right? Okay. Is that all right? You're gonna get 2 answers. You're gonna get a quadratic. You're not gonna have to use quadratic formula because it's gonna be factorable at the end. You're gonna make it equal 0. It'll be factorable. So that's a little early. That's good. I can give you the answer key so you get a chance to look at it. I want to do number 2 up here on the overhead, the graphing calculator problem. If you, if I got an absolute value question, first, yeah, let's do this, because there was a lot of mistakes on the quiz with this kind of problem. Oh, what's gonna be, Jeff? Yeah. One thing I saw way too much of is people put a 2 here. Right?
You turn that.
Oh, okay, thank you. What's order operations say comes last?
Last,
Yep.
addition.
Addition, subtraction, yeah. Isn't this 3 involved in a multiplication problem? So there's no way in hell you can make 5 minus 3 become 2, because there isn't a 3. There's a 3 times stuff, and I don't know what that is, right? Now, why is this problem, isn't this problem a lot easier for a lot of reasons? But the main reason this problem is easier is because what's already been done. Can I write the 2 cases? What would the 2 cases be for this?
X minus 1 is 11, or X minus 1 is minus 11.
And so why can't they do that with the problem I have here?
You gotta go with 5 over first and 5 minutes.
Yeah, you gotta isolate the absolute value. So in general, when I'm solving equations, we almost always, where's the variable? Isolate that part. Because then it can attack it directly. So what's the first thing I should do? I think you just said it, but.
Multiply 3 times the absolute value.
No, you can't do that.
It's not gonna work
Because I don't even know what that number is, because I have to do the absolute value first before I multiply by 3, yes?
Okay, so 5 minus 3.
Yeah,
times-
subtract 5.
because the answer is gonna become negative on the.
Hold on, we'll get there, we'll get there.
Add 3.
No, okay, good, that's the next step.
Divide by negative.
Remember what I said a while back? Whenever you think something cancels, slow down and look at the operations. So if I add 3, that's addition, what's this operation?
Addition.
That doesn't cancel, yeah.
Division.
Division.
It doesn't work.
Yeah, is there any reason to continue?
No.
Which is beautiful, because then, like, I don't want to, you got the fraction. Like, please don't make me work with the fraction. And so why can I stop right now and just say no solution? Because
It can't be
absolute
negative.
value can't be negative, yeah. Now, if you continue and you write your 2 cases, you will get 2 answers and they both will be wrong.
Yeah.
And we normally don't check absolute value equations, so what that takes is to notice when that happens and stop. If it says absolute value equals a negative, that can't be true, right? By definition, absolute value comes out positive, so there's no way to solve that equation. There's no answer that would work. No real or complex number makes that work. It's crazy.
Why is it over here instead of over here if it's x minus 2 for this?
I don't know. So yeah, it's kind of quick. Here's a beautiful example of, supposed to take this right to, right? I wrote it down, and then I did this. So this should be right to, so it should be over here. Yeah. Still averaging about 97 on my answer keys.
Right, so the answer here is wrong?
Right there, that problem right there, yes.
Okay, because
I would never say I don't ever make mistakes, because I'm a human being. So yeah, I wrote that, it goes right to, and then for some reason, I took it left. Yeah.
You are a robot.
Oh yeah, this one. So, quickly, let's see, if you want to play along, I've got some calculators up here if you want to borrow one. Yeah.
I think you did number 8 wrong with the calculation, yeah.
Eight. This one? This one we did together. Where's it wrong?
It should be 364, 105.
Sorry? Let's see.
Oh, I think that's after you plug it in to the thing.
Oh, yeah. How did I get 469? That's funky, Jeff. Oh, I think I tried to do that in my head, and it should be 529, yeah. Yeah, it should be 529. So 23 squared. I think I just tried to do that in my head. Yeah, okay. So this one. Just to remind you guys how to do this. If you put this in, if you want to play along, so go ahead and put this in the calculator. Oops, shit. Okay. Oh yeah, that's what I do. Yeah. I didn't add enough 60s of that.
Wow.
Now, if you try to graph this, it's a little bit crazy. But right there, can you see how many answers there are? How many x-intercepts there are?
3.
There's 3. There's no, there's not.
There's
There's 4, yeah.
Oh, that goes through and back up?
It's hard to see, but you can zoom in on it. But yeah, right there, it very much goes through. Yeah. So here's something kind of cool. I think I showed you this once before.
What,
If you hit
that?
zoom, the very first little dude's kind of nifty. It's my favorite little dude, zoom box.
Oh, yeah.
So if you do zoom box, you can move the little cursor over. If I hit enter and move down and over, that's going to be a box that's going to open up. And it's going to zoom in just on that piece. And then you can definitely tell that it goes through twice, yeah. How many answers are there supposed to be?
It's supposed to be 4.
Good, and I already got 4, so I don't need
Okay,
any
sure.
complex solutions, yeah.
Leading exponent is a 4. So therefore you
Yes.
gotta have 4.
How do I find one of these intercepts? What do I do to find?
trace.
Yeah, hit second trace to go to calc. What do I want to calculate?
0.
A 0. It's going to ask me for
Left bound.
the left bound, so I'm going to put my cursor as close as I can to the answer. Hit left arrow a couple times. Then it's going to want a right bound, so I'll go back to the answer, hit the right arrow a couple times, so I'm definitely on the right side of it. And then it wants a guess, so I'm going to put my cursor as close as I can. So there's one answer. One x-intercept. Yeah. So then I can just do the same thing. Now, I want you to notice something. Is everybody okay with that? On the test, I'm not going to give you one where you have to do that 4 times.
I kind of missed the very first part, so I entered the equation, then I go to trace.
Go to the equation. Did you do the part where I zoomed? So it looks like
Can I
that.
press graph first?
Yeah.
Mine says error invalid dimension.
Somebody used statistics for your hit second y equals. And then hit, don't worry about this, everybody.
Quit, now it says quit.
Quit. Second y equals, and you'll get this.
Yeah.
Now hit number 5. I'm sorry, number 4. Yeah.
It says plot 1 is on.
Hit number 4. And
Plot's off.
now hit graph. have this?
Coming, hold on. Yeah, I do.
So, let's find this guy here. Let's find this one's gonna be a little bit tricky, because this is kinda steep. But if I hit second trace to get to calculate, I wanna calculate a 0, that's another name for the x-intercept. Now if I move my cursor over, you can see how quickly it goes. Let me bring it back, there it is. Yeehaw.
Great.
It's coming. Where you at, little dude? Oh, did I already pass? Yeah, this is way steep.
I can't even find my cursor.
Yeah, it's pretty steep. Watch this. Watch the y equals here right now. Watch the y equals.
Found it.
Do you see how it's getting lower? And then it turned around. Now it's coming back up. Now it's positive, right? Okay, stay with me.
Well, I'm pressing left and right, and then I just got up to the
Just-
Y being 4.23.
Okay. So again, let's do this one here. Let's do this one. So I hit second, if I hit zoom box. Let's do this one like I did earlier.
How did you get to you can move the point like that?
Say again.
How'd you get it so you can move the point like that?
Alright, hit zoom box.
Z box?
So when I put the cursor somewhere at first, it's gonna be one corner of a box. If I hit enter, I can then open the box around any section of the graph I want to. And it's gonna zoom in on that section. The little piece looks like a parabola, right? It's not really parabolic, it looks like a parabola. And then I could get these two intercepts. So let's get this top one here. Let me stop for a minute. Philip, you with me?
I'm getting there. Zoom box. I don't press enter. Right, or then, oh, then that makes it box. There it is. Alright.
Let's see. So zoom box. Put your cursor in the corner of the box you want. Shit. Hit enter, and then down and over, it opens a box. And then you're gonna zoom in on that, sort of like CSI Enhance. Okay. And then define an intercept. Is that cool? Are you with me? Okay, so to find an intercept that hits second, calc 0. So if I want to find this intercept, get your cursor as close to it as you can, and then hit the left arrow a couple times. So now I'm to the left of the answer. Put the cursor back on it and hit the right arrow a couple times. So now I'm to the right of the answer. And then give it a good guess by putting the cursor as close as you can.
So it's 4.
Yep. That's another intercept.
So you want us just to find all of them?
Yes.
You want that big, that big
Yes.
line?
Okay.
Or the big line?
And the big idea for this one is, since we already got 4 answers, we don't need any complex ones. So we don't need any. If I do one thing, watch this. So again, look at this picture. Do you all understand if I lift this whole function up a little bit? Can you all see how it's only going to have 2 answers?
Or I'll go back to that graph.
Zoom 6. Do you all see if I lift this up a little bit? Won't this go up and it won't hit the x-axis? So it's only going to have these 2 answers, correct? So how would I lift it up? Well, I just make that 80.4. I just make that a little bit bigger. Let's make it 86.4. So how many real answers does this have now? 2. How many total answers is this supposed to have?
4.
So how many complex answers does it have?
2.
2. Yeah.
So
Say again.
86.
Yeah, all I did there was I could give you a problem where,
Accidentally cleared the whole thing.
yeah, I could give you a problem where it's only got so many real numbers, so it's the other ones are gonna have to be complex. So if I had a fifth power and it had one real answer, how many complex answers does it have? If I had a fifth power function and it had one real answer,
Four,
it has to have 4 complex answers, because I know it's supposed to have 5 total answers, yeah? Yes?
So the ones that go through are the real or the complex? Like the two like super long lines? These two, yeah.
Yeah, so are there real x-intercepts there?
Yes.
Yeah. How do I know they're real? Because they show up on this. This is a graph of real functions. This does not hit the x-axis, so it looks like there's no x-intercepts. But if I do that weird thing where they pick it up and look at the other dimension, it's going to have complex answers.
Is that this problem?
Again, I added 6 to it so that I lifted it up just to show you what could happen, right? So in this case, I have 2 real answers. I must have 2 complex answers because I know I'm supposed to have 4 total answers.
How do you reach the complex answer? You go second calc?
How do I do what now?
How do you reach the left two answers? It should be second calc and the left.
How do I determine them?
Yeah.
Yeah, so on this specific problem, do you all agree this is really steep?
Yeah.
Alright, so what I could do is I could make the y min and max
In a window.
bigger. Still pretty steep, but look at this one, this is not nearly as steep anymore, right? Down here somewhere it turns, do you guys agree with me? Yeah, actually let me make it the same function again, because I changed it. Okay. This side's looking a lot better, so let me make the y min even lower. Okay, that looks, I can see now it looks a little more parabolic here, yeah? You guys with me? Because I know there's an answer, there's a turning point down there somewhere. So let's see, if I try to do second calc 0, and I move back, let's try to get this one back here. How do I do it? I get my cursor as close to the answer as I can get. And then I hit the left arrow once, twice. Enter. Get the cursor back to the answer, hit the right arrow once, twice. Because then I'm definitely to the right of the answer. Enter. Then it wants a guess for me, so I get my cursor back as close as I can. Enter. And there's that negative 6, 7 that I got. So if I give you a problem like this on the test, I'll give you one that's not quite as steep, so you don't have to kind of remember to do that.
I'm on the right side of the steep one. So what I do?
You're on the what now? Sorry?
I'm on the right side of the steep one.
Did you change the window?
Yeah.
Okay.
Oh yeah, I changed it. Yeah, to 100. 400. I guess I can make the minute. All right.
Yeah, it makes it a little bit better. So you're looking at this one here. So let me do it one more time. Calc 0. Get as close as you can to the answer you want. Hit the left arrow twice. So you're to the left of the answer. Enter. Come back as close as you can get, and then hit the right arrow twice. Now you're to the right of the answer.
Yeah, I'm on the calc 0, second calc 0. But yeah, but my cursor's on the right side of the big one.
Of course, you can put your cursor wherever you want to. So do you want to find this one?
Yeah.
Okay.
What I
So
do?
get your cursor as close to this one as you can.
Do I press zoom? Or what do I-
Left and right. No. Left and right. Move your cursor around. Get your cursor as close to that one as you can.
Oh, there we go. Got it. Yeah, and then you enter.
No. The question is a left bound. So I'm going to hit the left arrow twice. So now I'm to the left of the answer. Enter.
Yeah.
Now come back to the answer close to it and then hit the right arrow twice. So then I'm to the right of the answer. Enter.
Right arrow. Yes.
And then come back as close as you can get for a guess. Enter. Let me see. What have we not talked about here? Well, like I said, number 5, hopefully that kind of problem's not too crazy. Number 6, there could be a billion different answers, but what has to happen on number 6 to not be a 1-to-1?
Just doesn't pass the horizontal line test.
Exactly. So you just need any function that would kind of like turn like this, because then it wouldn't pass the horizontal line test. So I gave one example. Yeah.
Does one-to-one mean we pass both the vertical line test and the horizontal line test?
To be a function, it's got to pass the vertical line test. To be a 1-to-1 function, it also has to pass the horizontal line.
So both of them.
Let's see. We did 7. We did 8. We talked about 9A. We talked about 9B. We did an example like 9B. Never know. We didn't talk about number 4 though, but number 4 is like, sorry. No worries. It's like that problem we did with the triangle. I don't know if any of you guys looked at, make sure I don't have grades in here. Oops. There we go. Oh, there, okay, good. Look this problem up. So it's at page 418. There we go. Number 68. Yeah. Now, this is a problem I thought I'd get some questions on, but I feel like maybe some of you guys just didn't quite get to this problem, which is understandable. You got a lot of homework to do, but find the dimensions of the rectangular dog park producing the greatest area if it's split into 3 sections of the same size. So can you envision this in your head? Maybe there's like one section for small dogs, one for medium, one for big. Does that make sense? That could be one reason why they want to do this, right? So that the big dogs aren't like bullying up on the small dogs. Can you guys see how this, now if I give you this kind of problem, I might give you the picture, just because if you can't draw the picture, you're not going to know how to set anything up. But how would this look? I want a rectangular dog park that's broken up into 3 sections.
Just put 2 lines in the middle at
Yeah.
equal distance.
What did I? Please don't tell me I made it 4 sections. Okay, thank God. So I've got some variables. What are the things I don't know? Because the question is find the dimensions, right? So the things I don't know are like how wide it is and how long it is. Is that cool? So I got 500 feet of fencing. What does the 500 feet of fencing need to go into creating?
The fence.
How many X lengths?
3.
Let's get more specific than the fence.
3.
Yeah. How many X's?
1. 2.
2.
Oh my gosh, I already.
2 of those. And how many Y parts?
1, 2, 4.
4.
Why is it 4? Oh. why
Because
is
there's 4. How many fence lines do I need going up and down? 4. Yes. Okay. So I want to everybody cool with the picture. This is 1, 2, 3 sections, right? How do I create 3 sections? Don't only need 1 on each side to have a rectangle, and don't I need 2 in the middle to cut it up into 3 sections, correct? So how many Y pieces do I need? 4. And what is it that created those? The 500 feet of fencing. Okay. This is what they tell me. What do they ask me?
You get the maximum area.
Maximum area. What's the area of this? Don't overthink it.
X times Y.
Yeah. And you could argue about the fence takes up some of, no, we're going to assume it's really thin fence.
Well, if each of those was a square, you'd have maximum area.
No. Nope. Doesn't work that way.
Can't work that way.
So if I can solve this equation for X or Y, I can plug it in here just like we did with the triangle. I can't work with this equation because there's too many unknowns. But I know this is true. So can't I solve this for x? Right, subtract 4y, divide by 2. What do you get? You'll get, if I divide by 2, I'll get 250. This will be 2y and I subtract it. Right, so I'm kind of skipping a couple steps there, but you can solve for x. And then I know what x is, correct? I know x is this, so then I can put this in there. And then I get a quadratic, and then I can do the shortcut, negative b over 2a. So basically, right now, if there's a question that says find the maximum or the minimum something, you want to set up an equation that's quadratic, because then you can just find the vertex. The vertex will be where the max or the min happens. If I take this and I put it in here and I multiply, I'm going to get a y squared piece, correct? So it's going to be quadratic. It's going to be parabolic. Okay. And then you can just follow the work on the key if you want to. You can try it yourself, yeah. Okay. I'm going to put this up on Canvas, but there's a study jam that's happening March 14th. And of course, it's kind of funny we picked March 14th because I don't know if you guys know that March 14th is Pi Day. Because what's pi? Well, how do we normally approximate pi? 3.14. And there's not million, there's an infinite number of numbers after that, but March 14th. Math people geek out about March 14th, so that's partially why we did it that day. But I'll send you the information. Of course, for us, the most immediate thing we're concerned about is Monday. Monday's the test. I'll be in class early, like always, so if you want to come a little early, I'll be here. If you want to email me questions, I'll get to you. All right, guys.